Welcome guys, welcome guys. So in this video, we are just trying to compute the next snowflake. So we will compute area and parameters. Okay, so let's quickly say that this is the I should say what? I should say the first iteration, and the next will become like this, right? Next will become like this. This one, okay. And the third and the second will be just this is second, and the third will be so on each side there will be a new small triangle happens, right? And the fourth will be much more complicated, but just keep going. Okay, and I mean I will not do it. Okay, so the first things, let's quickly compute the parameter. So parameter is somehow like trivial, right? Because in the first one that, okay, let's say this is S, right? So the first one, we should get a 3S, right? So let's start from this 3S. How about next one, right? So if we see a next one that, right, so let's say, so for each line they become this, right? So it become like so this is S, and this is 3s divided by 3s divided by 3, right? So this is total is 4s divided by 3, right? So you will just times 4 divided by 3, so it's 4s, right? And the next you will get times, keep going. Okay, so let's quickly give the parameter. Okay, so the parameter at n stage will be 3s times 4 to the divided by 3n. Right, this is trivial, right? Because n is equals to 1, that you get 4s. So this is first one. Okay, so I think I should assume that this is 0. Okay. So this is the 0 stage, just one triangle. One stage, two stage, keep going. Okay, so the theorem is basically trivial if n goes to infinity. I call it Pn. Pn will goes to infinity. So infinite parameter. Okay, so next go to the area. Okay, area. I change the color. So what is area? Okay, maybe this one. So in the beginning, that let's say at 0 stage, let's say this area is just maybe that we just count how many triangles. Okay, so let's first count the triangle. So in the 0 stage, we have like one triangle, right? But in the first stage, what we have is, well, we'll have 3, right? So total we have 4 triangles, right? And then this one will be what? Will be 16 triangles, right? Keep going. So basically, right? So basically, how many triangles we have? Right, so in the totally beginning, we should have 4 to n, right, triangle. Right, but what about area, right? So in the first one, we get the area. Let's say if this is the A0, okay, and the next will be A0, right, plus A0. So because the volume, right, so the side is basically string 1 to divide by 3. So volume will be this, right, but times 3. So it will be 4A naught divided by 3. Right, and what is the next is that A0 divided by 3 times plus something, right? So in the next that there will be how many triangles happen, right? There will be 1, 2, right? So basically total increase like 12, right? So we get the 12 A naught divided by, right? So we divide by, so now each side, right? Each side is is 1 over 9, right? So it's 81. Right, so now you see the pattern, right? So we can keep computing. Right, so for the general n, our an, let's say, and the first one is a naught, right? A naught is very trivial. The first one should be right. The first one should be what? The first one is that's a this one, right? And the second one is this one, right? So one can check that this one is what? This one is just basically 3/4 9 to 2 squared. Oh, you see? Okay, so now we need to say that why this is the next one. And the reason is simple, right? Because you totally have let's say so this 3 comes from that they always increase 3. Okay, and this 4, right? This 4 comes right. So for each one, right? So the triangle we start at 4, right? So we total will have 4 triangles. But if I minus 4 minus 1 divided by this is the how many triangles how many triangles exist. And for such triangles, for such 4 minus 1 triangle, that area if that area is as a not something x, then this one will be x divided by 9, right? So that means there should be 4 divided by 9. So 4 divided by 9 is the ratio, just come down here. Okay, now this ratio just the initial conditions, right? You can check, right? So for next that we do the same thing and just times this. Okay. Basically, you need some observations, right? But I think it's not difficult. So finally, an will be just a naught 1 plus this one, right? So we just keep going. So this an will be if I do it carefully, I will get let's say a naught that okay. So we can compute it by just using the formula. The first term is 9/4. The ratio is 4 divided by 9. 1 minus 4 divided by 9 to the power, let's say n plus 1. Okay, so finally an will be a0 divided by 5, a minus 3 4 divided by 9. So just the brute force computation. So as n goes to infinity, the limit of the flake will be 8 times a naught divided by 5. Okay, so it's finite. Okay, so now we have constructed such a curve, right? The first one is that the perimeter is infinite. Right. Second is but the area is finite. Okay. Okay, so this is very interesting. Okay, so suppose so let's build some number, right? If let's say if s is just let's say if this is s, right, then the total will be 8 divided by 5 a naught. So now a naught is just the area of equilateral triangle, so it's square root of 3 divided by 4. Okay, so the answer will be this. This is s squared, right? Okay, and I think it's enough for today. And the next time we will compute some other, like the Cantor dimension or some fractional dimension for different kind of space. And I will see you guys in the next videos.